You are falling feet first into a supermassive black hole. No spaceship. No escape. The glowing accretion disk screams past you in a blazing ring of fire. Stars behind you stretch into infinite streaks. Time itself warps, your friends watching from afar see you frozen forever at the edge, but for you, the plunge accelerates. Your body begins to stretch, longer, thinner, as gravity tears you apart atom by atom. And at the center? A point where space ends, time dies, and the laws of physics scream surrender. This isn't sci-fi. This is what cutting-edge science says would really happen if you fell into a black hole. And today, we're going all the way in. No turning back. Black holes aren't just the universe's most terrifying monsters, they're the ultimate reality breakers. Born from the explosive deaths of giant stars or lurking as billion solar mass behemoths at galaxy centers, these cosmic voids warp spacetime so violently that light itself can't escape. Einstein predicted them over 100 years ago, but we didn't truly see one until the Event Horizon Telescope captured that iconic glowing orange ring in 2019, and then our own Milky Way's Sagittarius A** in 2022. Fast forward to 2025, NASA's mind-melting simulations let us plunge virtually into these beasts. JWST is spotting ancient black holes that shouldn't exist, and quantum physicists are battling over whether falling in erases you, or rewrites the entire universe's information. This isn't some watered-down overview. This is the full, uncensored deep dive, the brutal physics of spaghettification, the nightmare of infinite tidal forces, the paradox that could destroy quantum mechanics, and the wild theories about what lies at the singularity. We'll ride NASA's latest visualizations, unpack Hawking's forbidden radiation, and confront the firewall that might incinerate you instantly. By the end, you'll never look at the night sky the same way. Because out there, right now, these invisible predators are devouring stars, merging in cataclysmic collisions detected by LIGO, and hiding secrets that could unlock quantum gravity itself. Strap in. Gravity's about to get heavy. We're crossing the event horizon, together. In the fiery crucible of the cosmos, where stars live and die in cataclysmic glory, black holes are forged like gods of destruction from the ashes of the universe's mightiest warriors. Picture this, a colossal star, 20 times the mass of our Sun, has burned through its nuclear fuel after billions of years of radiant fury. Its core, once a blazing heart of fusion, can no longer hold back the relentless crush of gravity, the ultimate force that shapes reality itself. The collapse begins. In a heartbeat, the star's innards implode at nearly the speed of light, compressing matter into a denser hell than you can imagine. Temperatures soar to trillions of degrees, neutrons smash together, and the outer layers explode outward in a supernova blast brighter than a billion suns combined. This is no gentle fade, it's a cosmic apocalypse, hurling shockwaves that seed new stars and planets across galaxies. But at the center? Silence. Darkness. A point of no return. What emerges is the singularity, a zero-volume, infinite-density nightmare where the laws of physics shatter like glass under a hammer. Surrounding it, the event horizon, that invisible veil where gravity's grip becomes absolute. Cross it, and even light, the fastest thing in existence, is enslaved forever. These stellar mass black holes, weighing up to 100 solar masses, roam the void like stealthy predators, devouring stray gas clouds and unwary stars. But wait, the universe's true titans are the supermassive black holes, lurking at the hearts of galaxies like ours. Sagittarius A, our Milky Way's beast, clocks in at 4 million solar masses, born perhaps from the chaotic mergers of ancient star clusters or direct collapse in the Big Bang's afterglow. By 2025, JWST had spied these monsters feasting in the early universe, growing faster than theories predicted, challenging everything we thought we knew. And don't forget the primordial ones, theoretical relics from the universe's infancy, tinier than atoms yet denser than mountains, potentially explaining dark matter's mysteries. Around these beasts swirl accretion disks, swirling maelstrom of superheated plasma, glowing with X-rays as matter spirals in, powering quasars that outshine entire galaxies. Friction heats the gas to billions of degrees, unleashing jets of particles at near-light speed, carving through space like cosmic lasers. This birth isn't random chaos, it's Einstein's general relativity in action, gravity warping spacetime into a bottomless well. Simulations from NASA and ESA in 2025 let us witness these births in stunning detail, stars crumpling, horizons forming, and the universe trembling. Black holes aren't voids, they're the engines of creation and destruction, recycling matter in the grand cycle of existence. Yet, as we stand on the brink, one question burns: what if you were the one falling? The beast awakens. The plunge begins. You've crossed the cosmic line. The event horizon looms, not as a physical wall, but as the invisible boundary where gravity declares total war on escape. This is the Schwarzschild radius, the death sentence written in Einstein's equations. For a black hole the mass of the Sun, it's a mere 3 kilometers across. For Sagittarius A*, our galactic monster at 4 million solar masses. A whopping 12 million kilometers, big enough to swallow the orbit of Mercury twice over. From far away, the horror is frozen in time. Gravitational redshift drags light to bloody crimson, then infrared, then gone. To distant watchers, you slow-motion crawl toward the horizon, photons stretching longer and dimmer until you fade into an eternal silhouette etched on the black hole's glowing edge. Billions of years could pass outside while you hover there, a ghost trapped in the universe's memory. But inside your frame, no drama. No burning. No crushing, yet. For a supermassive beast, the tidal forces near the horizon are surprisingly gentle. You glide across the point of no return as smoothly as falling through empty space. No fireworks. No alarm bells. The laws of physics don't scream, they simply change allegiance. Light bends inward, the universe behind you compresses into a shrinking bright circle overhead, while ahead lies only darkness pulling harder. NASA's 2025 black hole plunge simulations capture this nightmare in breathtaking detail. The accretion disk warps into a razor-thin halo above and below, relativistic beaming turns one side blindingly bright while the other plunges into shadow. Stars circle like moths around an invisible flame, their light smeared into glowing arcs by the curvature of spacetime itself. You're inside the cage now, the event horizon has sealed shut behind you like a one-way mirror. Yet controversy rages among physicists. Does a firewall of searing energy await at the boundary, vaporizing anything that crosses to preserve quantum information? Or is the horizon truly smooth, as general relativity demands? The debate pits Einstein against quantum mechanics in a showdown that could rewrite reality. One thing is certain, once you cross, the future has only one direction, toward the singularity. Causality itself bends, every path in spacetime leads inward. You can no more choose to turn back than you can choose to travel backward in time. The universe outside ages trillions of years in moments. Civilizations rise and fall while you fall. You're inside now. The event horizon is behind you. The universe outside is shrinking into a tiny, bright pinprick above your head. But the real nightmare is just beginning. Tidal forces, the difference in gravitational pull between your head and your feet, have been gentle so far. For a supermassive black hole like Sagittarius A*, the horizon is so vast that the gradient is subtle, at first. But as you fall deeper, the gradient turns into a guillotine. Your feet are closer to the singularity than your head. Gravity pulls harder on them. The difference is small at first, barely noticeable. Then it grows. Your legs stretch downward. Your torso follows. Your arms, your neck, your skull, every part of you is being yanked in different directions at different strengths. You're literally being stretched like dough. This is spaghettification. The term is darkly perfect. Your body elongates into a thin, noodle-like strand. Bones snap. Muscles tear. Blood vessels rupture. Skin splits. Every cell is pulled apart molecule by molecule. For a stellar mass black hole, this agony starts before you even reach the horizon. your body would be shredded into plasma while still visible from the outside, a frozen scream of agony etched in time. But for the supermassive giants, the real horror is psychological. You might survive the crossing intact. You might even have time to think, I'm okay. I'm still in one piece. Then the stretch begins. Slowly. Inevitably. You watch in helpless terror as your legs elongate, your torso thins, and your perspective warps. You become a human straw being sucked toward the center. And it's not just your body. The very atoms that make you up are being torn apart. Electrons ripped from nuclei. Nuclei themselves stretched and fractured. The electromagnetic forces that hold you together are no match for gravity's relentless pull. Some physicists propose a firewall at the horizon, a wall of ultra-high-energy particles that would incinerate you instantly, vaporizing your body into a cloud of radiation to preserve quantum information. If true, the death is mercifully fast. If not, you face the full, drawn-out agony of spaghettification. NASA's latest plunge simulations, 2025, show this in horrifying clarity. The falling observer's body distorts into a glowing, elongated streak, tidal forces lighting up the skin like a comet tail before the final crush. The camera shakes, the screen warps, the colors bleed into blue-shifted white as the singularity approaches. There is no escape. No heroic last-second maneuver. Just the slow, inevitable stretching of everything you are, until you are nothing but a thin thread of matter racing toward the end of space and time. This is the moment the universe stops being kind. This is the stretch of doom. You're deep inside now. Spaghettified into a glowing ribbon of plasma, racing toward doom. But something far weirder than physical destruction is happening. Time itself is betraying you. Einstein's greatest revelation, general relativity, unleashes its full madness here. The closer you get to the singularity, the more gravity warps the fabric of spacetime. For you, the faller, time ticks normally at first. Your watch runs fine. Your thoughts race. But to the outside universe? You're living in extreme slow motion. Imagine your best friend watching from a safe distance with the most powerful telescope ever built. They see you approach the event horizon, and then you just stop. Your image freezes, redshifted into invisibility over eons. Entire civilizations rise, conquer the stars, burn out, and die while your frozen silhouette lingers on the horizon like a cosmic photograph. Trillions of years pass outside. The last stars flicker out. The universe itself approaches heat death. And still, in their view, you haven't fully crossed. But for you? Seconds. Minutes. Maybe hours if the black hole is truly supermassive. You experience the full plunge in what feels like a short, terrifying ride. Time dilation isn't just extreme, it's absolute. Your personal clock and the universe's clock have divorced forever. NASA's 2025 visualizations blow this wide open. As you fall, the outside universe blue shifts into a blazing point of light overhead, accelerating like a movie on fast forward. Galaxies evolve, collide, fade, all in moments. The accretion disk whips around you in relativistic frenzy, one side Doppler boosted into X-ray fury, the other plunging into darkness. Spacetime folds like origami, turning the path to the singularity into the only possible future. Physicists map this insanity with Penrose diagrams, spacetime charts where the entire future of the universe compresses into a finite space. Inside the horizon, every direction points inward. Up, down, left, right, all roads lead to the singularity. You could fire rockets in any direction, you'd still hit the center faster. Causality itself is imprisoned. And the mind killer? The no-hair theorem. Black holes remember nothing of what they eat except mass, charge, and spin. Your entire life, memories, personality, every atom that made you, gets crushed into featureless information smeared across the horizon. Or does it? That's the battleground of the information paradox we'll hit later. Wormhole dreamers whisper wilder ideas, maybe rotating, black holes twist spacetime into ring singularities you could theoretically skirt, emerging in another universe or time. But the math says instability, any attempt collapses the throat into crushing chaos. Time isn't just warped here. It's weaponized. You live your final moments while the cosmos ages to death outside. You become a relic of a universe that no longer exists. You're not just falling through space anymore. You're falling out of time itself. And the singularity is ticking closer. You're almost there. The last remnants of your spaghettified self, a glowing thread of plasma, race inward at the speed of light. The universe has collapsed to a pinpoint behind you. Time has lost all meaning. And ahead lies the final boss of the cosmos, the singularity. This is where physics throws up its hands and screams, "I quit." General relativity, Einstein's unbreakable masterpiece, predicts a point of infinite density and zero volume. Spacetime curvature goes off the charts, infinity. Sci-fi? Maybe. But top physicists in 2025 are running supercomputer simulations blending quantum gravity theories like loop quantum gravity and AD/CFT correspondence, hinting that the singularity might not be the end, but a transformation. Yet no one knows. We can't peek inside. The event horizon blocks all signals. The singularity is shielded by the ultimate cosmic censorship, nature's way of hiding its naked breakdowns. One thing is undeniable, when you hit it, you're gone. Not in pain. Not in time. Just, erased from this spacetime. Your story ends where the laws of physics end. Or does it? Because the information paradox is screaming from the horizon, quantum mechanics says information can never be destroyed. So where does you go? Is your essence smeared across the horizon like a hologram? Leaked out slowly via Hawking radiation? Or reborn in another reality? The singularity isn't just the heart of darkness. It's the greatest unsolved mystery in physics. The place where Einstein and quantum mechanics go to war. And you, whatever's left of you, are the battlefield. Welcome to the end of everything we understand. They were supposed to be eternal. Immortal prisons swallowing everything, growing forever, the ultimate victors in gravity's war on the universe. But in 1974, a brilliant mind named Stephen Hawking dropped a bomb that changed everything. Black holes aren't completely black. They glow. They leak. And over insane timescales, they die. It starts at the event horizon's edge, where quantum mechanics refuses to bow to gravity. In the vacuum of space, virtual particle pairs constantly pop into existence, borrowing energy from the void, then annihilating each other almost instantly. But right at the horizon, something wild happens. One particle falls in. The other escapes. To conserve energy, the black hole pays the price, it loses a tiny bit of mass. That escaped particle. It's real now. To a distant observer, the black hole emits a faint thermal glow, Hawking radiation. For massive black holes, this evaporation is glacially slow. Our galaxy's Sagittarius A** would take 10 to the power of 100 years, way longer than the age of the universe, to shrink noticeably. But tiny primordial black holes. They screen radiation, heating up and exploding in gamma-ray fireworks that could light up the cosmos. This isn't just escape, it's rebellion. Black holes shrink, heat up, and eventually vanish in a final burst. The bigger they are, the colder and slower they evaporate, the smaller, the hotter and faster. In the far future, when stars burn out and protons decay, black holes will dominate, only to fade away, leaving a cold, empty universe bathed in their dying whispers. But here's the paradox that keeps physicists up at night: if a black hole evaporates completely, where does all the information go? Quantum rules say information can't be destroyed. Yet general relativity says it's crushed at the singularity and lost forever. Hawking's discovery sparked the information paradox, a clash that demands a theory of quantum gravity to resolve. Solutions like holography suggest everything's encoded on the horizon like a cosmic hard drive, leaked back via radiation. 2025 simulations and AD/CFT models are closing in, but the answer could rewrite reality. Black holes aren't indestructible gods. They're temporary. They recycle matter and energy back into the universe. They force us to confront the deepest mysteries: time, information, the fate of everything. Eternal darkness? No. Even the void has an expiration date. And when the last black hole fades, what will be left? We've never touched one. But we're closer than ever to staring into the abyss, and it's staring back. The Event Horizon Telescope delivered history, 2019's fuzzy orange ring of M87*S shadow, 2022's sharper shot of Sagittarius A star. By 2025, polarized images reveal twisting magnetic fields, confirming jets and accretion chaos. LIGO and Virgo have caught dozens of black hole mergers, ripples in spacetime screaming across billions of light-years, gravitational waves proving Einstein right again. NASA's 2024 to 2025 supercomputer simulations. Pure fire. Immersive plunges show the accretion disk warping into infernal rings, spaghettification in real time, time dilation madness, all rendered in 8K glory. JWST spots rogue ancient black holes seeding early galaxies, challenging formation theories. Upcoming LISA space detector will hunt primordial waves from the Big Bang itself. Could we make one? LHC rumors say mini black holes might pop in collisions, but physics says no, they'd evaporate instantly anyway. These beast-shaped galaxies trigger star birth, maybe even explain dark matter. We're on the cusp. Next-gen telescopes, quantum computers simulating horizons, probes staring closer. Black holes aren't myth. They're real. Detected. Visualized. And they're teaching us the universe's darkest secrets. The void is speaking. Are you listening? You've fallen with us, crossed the horizon, felt the stretch of spaghettification, watched time shatter, faced the singularity's infinite scream, and discovered even black holes fade. These cosmic monsters aren't just destroyers. They're the universe's greatest teachers, exposing gravity's tyranny, quantum rebellion, and the clash of our deepest theories. From stellar graves to galaxy hearts, they recycle stars, forge elements, and drive evolution on a cosmic scale. The terror is real, inescapable pull, information wars, realities unmade. But so is the wonder. In 2025, we've imaged their shadows, heard their collisions, and simulated their depths. Black holes remind us, the universe is brutal, beautiful, and far stranger than fiction. We're made of stardust, forged in supernovae, scattered by black hole winds. Gaze at the night sky tonight. Somewhere out there, these beasts roar in silence, holding secrets to quantum gravity, multiverses, and the ultimate fate. Black holes don't end stories. They rewrite them. Thanks for plunging into the void with me. The universe just got a whole lot darker, and infinitely more epic. Your brain is officially warped. If this plunge into black holes left you speechless, hit that like button. Let's get this to 1 million views. Subscribe and smash notifications for more insane deep dives, quantum immortality, Fermi paradox, and what if we fall into a wormhole next? Comment below right now, what terrified you most, spaghettification, the singularity, or black holes dying? Or what cosmic horror should we tackle next? Share this with every space nerd you know. The algorithm needs to know black holes are taking over. Thanks for watching. Stay curious. The universe is waiting. Let's go viral, together.